a payoff matrix so that when we've got a combination of whatever B plays of these three options, whatever A plays of those three options, we can see what the outcome is. In this case, in terms of the outcome for B, a 1 is a win, a -1 is a loss, and a 0 is a draw. And this is the payoff matrix that represents this situation. And if the player settles on playing one of those options all of the time, then they're going to lose because their opponent will be able to beat them because they can anticipate. What I want to say about this is I'm interested in game theory because it captures something that to me is very important about the way humans behave, that in large numbers they're predictable. You get 18 people is a fairly large number. 6 of them will be doing rock, 6 of them doing paper, 6 of them doing scissors. But the individuals are unpredictable. And that's actually not dissimilar to many situations that I see in life that I want to explain. A supermarket manager needs to know how many pints of milk, loaves of bread, cans of soda, whatever it is. They need to know how many are going to be sold in a day. They don't need to know which people are coming in order to work out what their stock needs to be. They don't need to know that Mr. Smith or Mrs. Brown is going to want an extra pint of milk this week. No, they want to know the behaviour in large numbers. In large numbers, the behaviour of people is predictable. It's unpredictable at the level of the individual. And that seems to me to be an important feature of human activity, which we might well bear in mind. But the other thing that is important is that a policymaker, a person who's preparing policy, the policymaker doesn't need to know about individuals. They need to know about the proportion of people who are going to be making a particular choice. They don't need to know what is B going to play this time. They simply need to know a third of the people are going to be playing paper, a third rock, a third scissors. That's it. Now the question for the policymakers, can I change the game slightly? Can I change the game so that instead of a third doing rock, a third doing paper, a third doing scissors, could I tweak it so that a few more people do rock? Could I make rock more attractive to people in order to persuade more people to play rock? But by the same token, that's the kind of question, look, if 50% of children are dropping out of school, can I produce a policy that tweaks it so that only 40% of people drop out of school? If I've got a teacher profession where the teaching profession, 90% are staying on until they retire and 10% are leaving after 2 years, can I tweak the situation? Can I change the rewards and the structure of rewards so that only 5% drop out at the end of the first year? The policymaker is less interested in the individuals than they are in the proportion of people choosing one choice or the other. Notice that when we were looking at cause and effect, if you knew the cause and the effect, you knew, or you aimed to find out, which people, which individuals that cause applied to and what the effect was going to be. That's not necessary. We don't need to think in terms of cause and effect in order to be effective policymakers. Now what I'm going to do now is I'm going to try and tweak the rewards. I would like B to play paper more often. I'm going to try and persuade B to play paper more often. So let me take away that. And instead of giving B a reward of 1 when she plays paper. I'm going to give B a reward of 2 when she plays paper. And when A plays paper, I'm going to give him a reward of 2. So now the reward for playing paper is higher than the reward for playing the others. I've given a bonus to A and B to play paper. I'm trying to encourage them to play paper. Now, I'm not going to do a formal analysis of this. There are good formal analyses of this rock, paper, scissors, where the rewards have been shifted slightly in order to encourage a player to play one game rather than another. And particularly there's a video by William Schilling that you can find on YouTube, goes through this particular sequence of rewards and what happens when we give that extra added incentive to play paper. When we make paper worth more, well, what happens is this. Originally, with the original reward structure, B played 33%, 33%, 33%. And now we've put in that extra reward for playing paper. What happens then? Well, there's a change in the proportion that the player should make. And it looks like this after the analysis that Schilling offers. 25% of the time, B should play rock. 25% of the time, they should play paper, and 50% of the time, they should play scissors. Now, that looks wrong. You'll understand, we thought we were increasing the incentives to play paper, so we would expect paper to become more frequently played. But what happens is, remember, a win for B is a loss for A. So this big win for B becomes a disincentive to A, so A is going to play that line less frequently. And if A is going to play that line less frequently, then B should not be aiming for that win so often. They should prefer to aim for a different outcome. And the different outcome that they should be aiming for is this one here. This is more likely if A is planning to be playing paper more frequently. So the incentives that we thought were going to function are actually disincentives. They don't increase the percentage of people that are playing paper, they decrease it. They don't increase the percentage of plays in which the B plays paper, they decrease it. So now we have a number of things that we can draw from this in terms of shaping an educational research project. We have an insight that people in large numbers behave according to regular patterns, even if the individuals do not. The behaviour of large groups may be predictable, even when the behaviour of individuals is not predictable. That incentives may act in perverse ways, and that policymakers don't need to know what individual people are doing in order to be able to cater for the large numbers of people that they have to deal with. And so we've got a model here. If we want to encourage more people to do science, then we need to think about the large numbers of people involved, what might encourage more people to do science, and it might not necessarily be increasing the benefits or increasing the rules for doing science. Now, if you look at this topic, or any topic, what's currently being done in terms of research, why don't people study science? It's because they don't have role models among their science teachers. There's a cause and there's an effect. If people only could see themselves reflected in their teachers, they would be encouraged to do the study. What you see, you can be. There's a cause and there's an effect. That doesn't necessarily work. What we might be thinking in terms of a better handle on policy is to say, let's see whether we can shape the decisions in order to model the decisions in order to see what different proportions of people will do. Notice that the explanation I aim for is not just looking for a cause for somebody to play scissors, a cause for somebody to play papers, or a cause for somebody to play stone. When I'm not looking for causes, I'm actually trying to predict the percentages of people who are taking each option, explaining not just why somebody does play scissors, but explaining why sometimes they play rock, sometimes they play paper, sometimes they play scissors. I'm trying to explain all of their choices, not simply one of them. So there's a whole wealth of thinking, and the reason I say I hope this is a challenging video in a good way is because I want you to take this away and think about what it means in terms of working out a research program to study why people leave the teaching profession, why people choose to study a subject, why people choose to, whatever they choose to do, what is it in the incentives that shapes those choices? Rather than looking for a cause and an effect, we can visualize human behavior not in terms of cause and effect, but in terms of something quite different.